Insulation is now a standard required item in home construction, and for good reason. It slows the movement of heat through walls, ceilings, and floors, and saves on energy consumption. Insulation creates what is called the thermal boundary, or thermal envelope of a home. This boundary protects a home from unwanted heat loss or heat gain.
Heat always moves from hot to cold. So in the summertime, when it's hot outside and you're air conditioning the house, heat is moving from outside to inside. Some materials block or restrict that flow of heat better than others. We call those materials having a higher R value or higher restrictive ability to block the flow of heat.
However, the R value of insulation is only achieved when it is installed properly. Improper installation reduces the R value and increases comfort problems.
Getting the insulation right throughout the building is the first big step in making sure the house is going to perform as it was designed, as what the homeowner is expecting.
To install insulation properly, there are 5 major rules to follow. No gaps, no voids, no misalignment, no wind intrusion, and no compression.
Whenever there's any of those problems, the insulation is not working up to the R value that it's supposed to have. And typically in a normal house, we might find dozens and dozens and dozens of places where all those things, one or more of those things, are happening, so that the R value that's printed on the little paper is not being achieved.
So, our comfort rule is the R value of insulation is achieved only if it is installed properly. There are many different types of insulation on the market now. Fiberglass bats, blown cellulose, cellulose spray, fiberglass spray, rock wool, and many others. All of them, when installed properly, perform well. But if installed improperly, they can all create energy and comfort problems. Insulation achieves its full R value only when it is allowed its full thickness. Anytime you compress insulation, such as when it is tucked behind electrical wires, boxes, and plumbing, it decreases the R value. A bat of insulation rated at R30, for example, when compressed to half its thickness, will only deliver about R15, half its value. Dan McFarland is a former insulation contractor and now works as a building science specialist. He says compression is one of the most common insulation mistakes.
In this situation, the framing contractor has furred out this 2x8 an additional 1.5 inches. This will accommodate an R30 bat of fiberglass. But the problem that we have is when the insulation contractor came behind him and installed his bats, he pushed them in too far, compressing them. Compressing the insulation means that they're not getting the full R value that they expect, and that's what they plan for, to have comfort up in this bonus room.
It is important to never force insulation into any spot. Instead, it should be carefully placed into the stud cavity, allowing it to maintain its full thickness and achieve its rated R value. When electrical wires or plumbing pipes are in the stud cavity, separate the insulation in the middle. Pull the back half of the bat behind the wire or pipe. Take the front half of the bat and place it on top of the wires and pipe. When you have an electrical box in a stud cavity, it's also important to split the insulation. Take the back part and slip it behind the box. Then lay the top part of the bat on top of the box and cut around it. Careful not to leave any gaps. If you follow this procedure in walls, ceilings, and floors, you will reduce the amount of compression and allow the insulation to work at its full R value. Insulation of attics is extremely important. Here we must balance proper ventilation with proper insulation. In a typical attic, you will find insulation pushed to the outer edge, exposed to the outdoor air which comes in through the soffit vent. Because insulation is not an air barrier, the wind can enter the insulation and leak into the conditioned space. This problem is known as wind intrusion.
if the wind blows and comes through the soffit vents, its first entry into the building will be through the end of the insulation. The unfortunate thing about air movement is that it always seeks the path of least resistance. So it's how porous is the insulation at that point, because the air coming through at that point often is at a high velocity. So it reduces the R value 3 to 4 feet all the way around the perimeter of the building.
Fixing this problem is easy and inexpensive. Cardboard wind baffles are available at most supply houses. They should be installed prior to insulation. The baffles block the air from entering the insulation through its exposed end, but still allow air coming through the soffit vent to circulate along the ridge. This provides needed attic ventilation, but protects the insulation from wind washing. In order for an insulation job to be effective, it must be free of voids, or holes in the thermal boundary. Remember, the thermal boundary should wrap around the entire house like a blanket and protect it from unwanted heat loss or heat gain. Holes in the thermal boundary allow unwanted heat in during the cooling season and expensive heat out during the winter. This can cause moisture problems, energy problems, and comfort problems.
This is an example of a void that's waiting to happen. The HVAC contractor has already installed the ductwork, which is going to make your job more difficult, having to get insulation into this cavity space here. If we don't insulate this well, we're going to have a comfort problem and increased energy bills. Paying attention to details like this will be very important in doing a good job on this house.
Voids can happen throughout a house, but there are a few places it's more likely to happen than others. Knee walls, such as in bonus rooms, can be problem areas. Dormers, stairs on exterior walls, vaulted ceilings, tubs or shower stalls on exterior walls, and shafts for utilities are all places to which you should pay extra attention. Misalignment occurs when there is distance between the insulation and the air barrier or sheet good, such as drywall. This gap allows air to circulate inside the cavity. This is called a convective loop and can cause big comfort problems.
Typically, everybody understands that warm air rises. That's a pretty fundamental thing. What people don't understand is that even in an enclosed cavity, you can have warm air rising. For instance, in a wall, if you've installed bad insulation and compressed it in so there are passages between the sheetrock and the paper facing, then as the air in that cavity heats up, it's going to rise, pull in cold air, and you're going to lose heat out the top. And if that's a significant amount, it can really have a comfort problem in the house.
Let's install some paper-faced batt insulation in a wall cavity to illustrate how misalignment can happen. We are using a side stapling or inset stapling technique to install our batts.
Let's take a look at what happens when our sheetrock contractor comes along and installs his sheetrock. With the inset stapling, we're still going to have air gaps here in the corners, and gaps are something that we're always trying to avoid. These gaps will allow air to flow behind the sheetrock, and this may create some either comfort problems or potential source for moisture problems down the road.
When installing batts, one simple way to avoid this particular problem is to staple the flange of the face paper to the front of the stud. This is called face stapling. You can see this eliminates the unwanted gaps. You can also use a friction fit technique. This involves cutting unfaced insulation to size and fitting it into the stud cavity. When using sprayed products, such as sprayed cellulose, it's easier to avoid misalignment problems because you actually fill the wall cavity with the insulating material, a system unlikely to leave any gaps.
The insulation should always be in contact with the air barrier of the building, no matter where that air barrier is located, so that in fact they're married to each other. That will produce a very good thermal boundary.
As we've heard, a good insulation job is continuous. That is, there are no gaps in the thermal boundary. Gaps commonly occur when bats are cut too short and leave a hole at the top of the stud cavity or at the bottom. Gaps can also occur when bats are cut too narrow to fit the stud cavity. The best rule of thumb is to measure the area you plan to insulate before you cut to ensure a tight, sure fit.
By getting the insulation right, what we're doing is we're avoiding comfort problems, the cold and hot spots within a building. We're eliminating potential areas that would inhibit the growth of mold and mildew. Sometimes they are quantum leaps. Sometimes we can see noticeable differences. We can measure those differences in our heating and cooling bills. Sometimes it's very subtle differences, such as just a comfort problem in a room.
Proper insulation of a home is important to its overall comfort. But without proper air sealing, some of that work just goes out the window. The air sealing of a home involves closing up any cracks or holes that allow unwanted air to leak in or out. Imagine leaving a window in your house open all day, year-round. In typical residential construction, the average home has air leaks equal to a window opening of about a foot. With proper air sealing, we can get that window nearly closed. We do that by sealing up unwanted holes in the air barrier. The air barrier of a home is the boundary which separates the indoor conditioned air from outdoor unconditioned air. A good example of this is the sheetrock ceiling between the living space and the attic. Sometimes air barriers are installed by framers and can be made out of a number of different materials: solid lumber, plywood, OSB, insulated sheathing, high-density cardboard such as thermoply, and even drywall can all act as an air barrier.
No matter whether it's the wall, a ceiling, or a floor, it is critical that we determine the location of the air barrier. Often, many trades think that placing insulation between the inside and the outside creates an air barrier, but they're wrong.
That's right. Insulation is not an air barrier. It slows the movement of heat, but it does not stop the flow of air. Watch what happens when smoke is blown through a piece of insulation. You can see the air moves easily through it. Installing insulation without a proper air barrier means unwanted air will leak into the living space and can cause comfort problems for homeowners.
Mistakes happen in every building we build. They're not intentional, but every one of the trades should be trained so that they can spot what makes their product not work as well as it should.
As an insulation and air sealing specialist, it's your job to spot breaks in the air barrier and seal them. Some of those gaps are harder to notice than others.
Knee walls in bonus rooms and cathedralized rooms are large contributors to comfort complaints. You as an insulation installer can certainly help this tremendously by taking insulated sheathing and installing it on the back side of the wall. Now we can see by putting the insulated sheathing on the back side, we've created a closed cavity which will reduce infiltration, give our insulation a backing when it's placed in the wall, and reduces also the amount of moisture that can migrate into this wall. We're now ready to install insulation in each cavity.
As we've said, in order for the air barrier to work, it must be continuous. Holes, no matter how small, can allow indoor air to leak out and outdoor air to leak in.
Here in the Southeast, one of the reasons that we're concerned about air infiltration is because of humidity. Bringing that moist, warm air into our homes, which is really one of the reasons why we have air conditioning, to create comfortable living environments. And of course, we also know that there's other things in the air, such as pollen and allergens and outdoor air pollution that's coming into the home. And if we can do our best to eliminate those coming into our living environment, the better off we're going to be.
Air sealing is an important part of eliminating air leaks. Luis Ramos is a trained air sealer and insulator with nearly a decade of experience. When sealing around windows and doors, Luis uses a closed-cell foam roping in between the window and the framing. Stuffing fiberglass in this gap will not work because fiberglass is not an air barrier. He also caulks wherever he has cut the roping to make sure the gap is completely sealed. It's also important to seal any holes left by plumbing and electrical penetrations. We've talked about air barriers, which prevent air leaks in a house, thermal barriers, which slow the flow of heat. Now a word about vapor barriers. Vapor barriers protect insulation and other materials by preventing unwanted moisture from seeping into a wall, ceiling, or floor assembly. Water vapor moves from warmer areas to colder areas, so where we put the vapor barrier depends on whether we do more heating or cooling of a house. If we do more heating, it goes on the inside of the insulation. If we do more cooling, it goes on the outside.
Moisture is one of the biggest problems facing builders today in homes. How we manage that moisture is going to help provide comfort and durability for the buildings that they are building. We know that the outdoor temperature is one of the factors involved in managing moisture. Some of the other factors involve the indoor environment, what the occupants are doing in those homes, the materials we're using in homes, and how those materials come together. Whether it be the wall assembly, the attic, the ceiling assembly, and the floor assembly, all those can make a difference as to whether moisture can move through the building or whether it's going to get trapped and then cause problems down the road. And in addition to that, we have to be aware of the local building codes in our areas that may impact on our building techniques.
Many different materials can act as vapor barriers. When installing dense packed cellulose, the nylon reinforced polyethylene that holds the cellulose in the wall cavity can act as a vapor barrier. When installing sprayed cellulose or unfaced fiberglass bats, stapling sheets of sealed polyethylene tightly over the stud assembly provides a vapor barrier. Coated craft face paper on bat insulation can be an effective vapor barrier. Any material that does not allow moisture to pass through it can act as a vapor barrier. As we wrap up, let's have a quick review. Our comfort rule is the R value of insulation is achieved only if it is installed properly. To install insulation properly, there are 5 major rules to follow. No gaps, no voids, no misalignment, no wind intrusion, and no compression. Air barriers prevent unwanted air from leaking into or out of a house. Insulation is not an air barrier. And finally, vapor barriers prevent moisture from getting into walls, floors, and ceilings. The work you do as an insulation and air sealing specialist has always been important. After all, a house is only as comfortable as its thermal envelope. Now you can become an even more important part of the building process. You can build comfort for years to come.